Welcome to Terrible Lizards, a podcast about dinosaurs with Dr. David Hone and Izzy Lawrence. On this week's episode, we learn about common but overlooked dinosaurs, the Psittacosaurus. Plus, Garret and Sabrina from I Know Dino ask a question not even Dave knows the answer to. Hello and welcome. We have got such a big opening for you now because no, it's not Stegosaurus, not yet. Wait, guys, wait for it. Okay, here we go. No, it's not Triceratops. We've already done Triceratops. No, it's
Psittacosaurus.
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 Nobody's going to click on this.
P-S-I-T-T-A-C-O, Psittaco, so with a silent Greek P at the front.
That's even stupider. Nobody's only... What? Psittacosaurus? What?
Yeah, so have you heard of psittacosis?
No! Nobody's heard of anything. I've heard of sitting down.
So psittacosis is a disease that you can catch from parrots, which you might have heard of, and it's the same root, because Psittacosaurus the translation is, it's the parrot lizard, or parrot dinosaur.
Oh my goodness, Dave, we're doomed. We're going to have no listeners left ever. A parrot dinosaur. Parrots are dinosaurs, we've established this.
But it's named well before that. No, Psittacosaurus, it's one of those animals, we did an episode on Protoceratops, and it's similar, well, in a number of ways, not least of which is, it's an early ceratopsian, but it's a very parallel animal to Protoceratops in the sense that it's one of those dinosaurs which, no, it's not an A-lister, but we know a hell of a lot about it, at least in part because we've got a hell of a lot of specimens of it. And so it's been really quite well studied, and there are, I think, arguably more specimens of Psittacosaurus than any other dinosaur, and probably by a very considerable margin as well.
Okay, so I've got so many questions. Yeah, first off, where, when, what, how?
It's an early Cretaceous animal. It's from China and Mongolia and that general region. I'd be very surprised if there weren't ones. In fact, I know there are ones in Russia. So yes, you've got Eastern China, or you've actually turned up in Western China as well, but China, Mongolia, Eastern Russia, so that very eastern block of East Asia. Early Cretaceous, when we talk about lots of feathered dinosaurs and liaoning and the J-hole biota and terms like that we've used, and you'll see a lot around, Psittacosaurus is one of the animals that's absolutely in there, but in lots of other fossil beds as well. So in particular, what you get for liaoning is, of course, these beds where everything's absolutely flat and there's all this volcanic ash, and you get this absolutely incredible, amazing, beautiful preservation, which is why you get all the feathered dinosaurs. And occasionally you get some other beds between them where the preservation actually is more normal, and it's 3D uncrushed whole skeletons just without all the soft tissue and stuff. Mostly we get Psittacosaurus in those, and so they're innumerably productive. This is why I said, there are thousands of specimens of Psittacosaurus probably knocking around in various collections in China. They are absolutely everywhere. Like every single little museum you go to has half a dozen.
There's never said, hey kids, come let's look at the Psittacosaurus.
No.
Where is that in the Natural History Museum? Where are they?
So they have a model of one. So if you go to the Natural History Museum in London, it's
not one of the moving ones, is it?
Yeah, it's the little one. So
is it the sleeping one?
It's the little green one that when you leave and it's sleeping and its chest just goes up and down slightly.
I know what we're talking about now. I know exactly what we're talking about. But this is a really small little dinosaur.
Yeah, they're mostly pretty tiny. So 3 feet long, metre or so long, including the tail. Really quite a small animal.
Do they get big? Are there bigger ones?
We'll get onto that.
We'll get onto that. Oh, it's so exciting. I know what we're talking about.
So yeah, but most of them are that size and smaller. They've got a classic taxonomic history where for ages every new specimen that was dug up got named as a new species. At one point there was something like 12 or even 14 species. That's now been boiled down to something like about 6, but I don't think anyone's ever sorted them out properly, at least in part because they are super common. There are loads and loads of them out there. There's also loads and loads of bits. So when you go to museums or when you see fossil dealers and stuff, you'll often see, and I've seen this just all over China, it's like, oh, look, we've got a dinosaur skeleton sale. It's a Psittacosaurus. And you take one look at it and go, that's at least 4 different animals bolted together. They're so common that they've just got the legs off one and the head off another and the body and tail, and they've chunked them all together. And you see these absolutely everywhere. I've been to a couple of dodgy, not quite clear who owns it or what it is, backstreet museums in Liaoning. And some of them have like 50 or 60 Psittacosaurus skeletons. And God knows how many of them are truly genuine in that it's an actual original real whole skeleton there, and how many of these have basically been bolted together from bits.
So, because we got so many sort of skeletons together, I know that the beds it's a bit difficult to say this all happened at once, but it tends to be, I mean, does this sort of show that they might be social? I assume they're herbivorous. I'm not...
We've got a couple of groups of them. Actually, we should go back. We still haven't really said what it looks like. You said know what it looks like.
I know what it looks like. It literally... Okay, I'm going to describe it. Imagine, like, a kid's drawing of a T-Rex that's really quite bad. So, it's got its arms
I'm
too
not sure
big.
this is helping.
No, it's really good. It's really good. It's really like a plastic T-Rex, okay, that's really not well designed and good. And then put, like, a turtle's head on it instead of a T-Rex head that's slightly smaller than a T-Rex head would be. I can't remember. I think it's got little cheek nodules.
Yes,
it's got
exactly.
Little cheek prongs coming out of it. And it looks, it's got a bird-like face. And it's got big chunky, and there's literally nothing exciting. It's brown, but it's kind of cute because it's got quite big eyes because it's quite small in its little box in the... I looked at that a lot when I was a kid.
Yeah.
That particular model. So I love Psittacosaurus.
So yeah, that's really quite good.
If you took the S out, it'd be a Pitasaurus. And I quite like that. That'd be nicer because that'd be like a bit of bread and you could have some hummus.
So they are an early relative of the ceratopsians. So this is pre-even Protoceratops. Psittacosaurus was probably bipedal, so they're still running around on their back legs, and it's before they've dropped down onto all fours. Though, as you say, they've got relatively long front legs. I'm sure they were okay on four legs, and at least a couple of the big ones were probably walking around on all fours too. They have this tiny little shelf at the back of the skull. If you get a skull of them, they've got like this little, even on a big skull that's like a, I'm holding my hands out trying to think of a comparable size, like a
rugby ball?
No, smaller than that, like a big melon or something like that. That shelf is like less than a centimetre. And of course, that will eventually go on to be the frill in Protoceratops and Triceratops, Styracosaurus and all the others. In Psittacosaurus and its relatives, it's like this rim almost at the back of the head. What it does have, though, as you say, the two big cheek spikes, or given their proper name, jugal bosses. We talked about jugal bosses in Protoceratops. You see these in later ceratopsians. Pentaceratops, which I don't think we've mentioned before.
No, that's the one with the 5 horns around the sides.
No, so it's a very close relative of Triceratops, and it's just got, frankly, I think, about the same size. But its jugal bosses are supposed to be really quite big, and therefore those are the 5th horns, because it's got the same 3 as Triceratops. So those big cheek spikes are an absolute commonality in ceratopsians. Animals like Psittacosaurus start off with big cheek spikes and basically no frill, and later on that frill massively expands. And the cheeks hang around, but they're mostly not that big. Certainly not compared to all the other ornamentation going on in ceratopsians.
So is it just because they like to, when they're sat in the tube or in public transport, they just like to give themselves a bit more space, so they swing their heads around and sort of like stab each other with their...
Well, somewhat inevitably, I think it's some form of sexual selection. Again, they're the same things doing the same thing. Yeah. The juveniles don't have them, the adults do. In Protoceratops, we suggested that they're growing pretty fast, which is one of these key features. Yada, yada, yada. In the case of these guys, they're much sharper and spikier than you see in most ceratopsians, where they're actually really quite rounded. I can imagine these could have been pretty good if you were smashing your head sideways into a rival in a way that wouldn't really work for a lot of the later ones.
Or maybe
I certainly wouldn't rule it out.
Just to your kids, so you could herd them and say, hey, press the bell, we're getting to our stop, or something like that. Just like, come on kids, this way, I'll spike you if you come too close. I don't know, as a herding implement. And they're just a very odd adaptation, just the side of your face to have a spike rather than the front or your hands or...
Yeah, I didn't design them, so I can't really...
I know you didn't. But, you do decide what all female Psittacosaurus find attractive. Psittacosaurus, Pitasaurus. Psittacosaurus. I'm going to get this right. They have got the word pitta and tacos in them, and I'm quite hungry.
So I had a massive lunch, so I'm not. So yeah, you're asking, like, you know, how social were they? So yeah, we find a lot of specimens, but mostly on their own, and I think that's mostly just because they were extremely numerous. There are a couple of groups known, one of which I found. Well, with several other people. So I was there with.
We can never on your own. It's a bad idea to go dinosaur hunting on your own.
Well, quite. So we were out in China, and this was me, Corwin Sullivan, Jonas Chouanier, and Michael Pittman, and we're a big group of Chinese colleagues, but the four of us had ended up together somewhat by chance, because we're normally out in pairs. And they may disagree, but I don't think any of them listen to this podcast, so I'll tell the story.
The Fantastic Four had all got their capes on, and they were trekking through the...
Well, so we were in Inner Mongolia, or at least the border of it, so northwest China, so quite a long way away from most of these things were found, and on our way to some of the classic late Cretaceous beds to go for Velociraptor and Protoceratops and that kind of stuff, and we'd stopped at this site, and it's told, you know, this is a chance to look for some lower Cretaceous stuff, which we hadn't really looked for and people hadn't dug up in this area. So we're just taking like an afternoon there and everyone just spreading out looking for stuff. And I was usually working with Corwin, so the two of us were as a pair and the other two were a pair. And we kind of met up and we're going like, we haven't really found much, haven't really seen very much. And then one of us, I want to say it was Mike, found a couple of bones and we're like, like right where we were in this little gully, and like, well, this is great. We just found something, now we're here. So we have a look around, and of course, I think we've talked about this before. We talked about, like, finding fossils. The first thing you do is, like, you're at the bottom of a valley, which is where you should be. It's probably eroded from somewhere. It'll come down a slope. So we walk up the slope, both sides, no sign of anything, but wandering, no, not a lot. Okay, sometimes you get just a couple of bones, or you just can't find it, whatever, and then, no, hang on, there's one over there. Go and find the next one. And did this, like, 4 or 5 times, and we're now really quite a long way from where we'd started. And we're giving up, and we're literally at the point of like giving up, and we're like, no, there's just nothing. Okay. And as we were about to go, I spotted another one. It's like, okay.
Dave spotted it. It's definitely Dave who spotted it, guys.
Yeah, the fourth or fifth bit. And it went like up a side channel and like around a corner, and there were 3 or 4 bones poking out of a wall. And we're like, well, this is great. This could really be something. When you've got 3 or 4, and we've already got these other bits, this is looking really great. So we're scraping away, and you're doing all the usual careful stuff and trying to find what's there, and time's getting on, and we've pulled out like 3 bones, and they're all broken because of course they've all eroded, and it's like these things going into the hill, and it's like we're leaving in like an hour or so, and we need to know if this is worth really putting the time and effort in, or is this just not going anywhere. And so I think I dug my hammer in like, you know, above where we were digging, but like, let's try and lever a big chunk off and just see what's back there, because if there's nothing and we're just these 3 or 4 bones, we'll leave it. Lifted it up, and you could, and it just split at that level, and you could see like about 12 or 15 bones going in, and like, oh, there's loads. Okay, brilliant. Okay, lever that back down, cover it all up, GPS, take photos, take some notes, go back to camp, or where we were meeting up, because I think we had camped at that point, tell everyone, show them what's going on. Great. Xu Xing, who was the leader of the project, said, okay, yeah, this looks really cool, very pleased with this, fine, yada, 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 think no more about it, because we'll get it on the way back. And Xu's field trips, this is what he did. You know, he had a team of technicians, he could send them off. He usually had us guys finding stuff and his team
doing the hard work.
Yeah, basically. It's fun. You know, so think no more about it. And it's probably like a year or 2 later that the others were back, because Corwin and I were working in China and the other 2 were visiting because they were doing their PhDs at the time. And someone mentioned, oh yeah, Xu, did anyone ever go and pick up those like Psittacosaurs we found? He's like, oh yeah, there were 6. Like, what? Yeah, we found a whole group going into that hill.
So they all died together?
Presumably. I've seen them. There's a jacket, so they were all taken out of the hill and they were prepped. I'd say 6. I can't remember exactly how many, but it was like, you know, it was more than 2. It was 4, 5 or 6, something like that. I think 6. And yeah, and this was 12 years ago now. I don't think they've ever been described, not put into the scientific literature. I know Xu thought they were a new species, though with Psittacosaurs, that's not saying very much, because as I say, their taxonomy is an absolute disaster. But yeah, but between the 4 of us, we found this cluster. So there's one group at least of them that I know about. So yeah, there's this cluster of juveniles known. There's an adult with some juveniles known. There's a couple of others that I've seen in a museum that I'm pretty sure is not genuine, as in someone's put some juveniles with an adult together. But certainly it's happened at least a couple of times with verified specimens that, you know, have not been bought off some random local dealer, but were dug up and prepped by a research team. So yeah, they do turn up in groups occasionally. Of course, that's always going to be, this is the problem with that kind of data. We talked about this with social stuff. Stuff that lives in groups is mostly going to die on its own, and occasionally stuff that lives on their own will die in a group because a drought or whatever has brought them together, and that's why it gets difficult. I would not at all be surprised if, on average, Psittacosaurus are in groups quite a bit. They're these small animals that don't eat much. They're pretty vulnerable to predators. They don't have a lot of defences. Being in a group is probably a good idea.
You said they're only a couple of metres long. How tall are they on their hind legs? I mean, I know they're not sort of like walking around like...
Well, most of them are a metre long, so they're not that big. So yeah, they're going to be knee-high or so on a human.
So literally that one in the Natural History Museum is an accurate adult model?
Yeah, so life-size. Oh, yeah, for anyone who's seen it, they're really quite small. Yeah, and we've got small juveniles down to like 30, 40 centimetres. But we've also got some bigger ones, and that's where I was pausing, because I was saying, mostly our Psittacosaurus specimens come from these like intermediate beds that are more normal preservation. We have a couple that are from the more classic feathered dinosaurs where they're flat, but they've got everything. And in particular, there's a very famous one that's in Frankfurt, which has been described like 4 different times now for all its various features. It's squidged, but it's also still kind of in 3D. So the bones are in twisted, really good shape, and they haven't all... Well, so often when you see this with the feathered dinosaurs, the specimen looks amazing at first glance, and when you actually look at it close up, you see that like every bone is shattered. And these aren't like that at all. You know, if you could pull them out, they'd be in pretty good nick. It's kind of squished underneath and sideways. So if you imagine the animal standing on all fours, and you lay down next to it on its side, and we're looking up kind of through like a 45 degrees angle. I mean,
this sounds like something you wouldn't want to do in any...
But that's the plane in which it's been crushed. So like you see the underside of the feet and the underside of the head and the belly and things like this, but kind of at 45 degrees from the side on, so you're not straight underneath. So it's all really quite mangled in some odd ways, and you see the bones at an odd position. But the bones are in... It's huge. That one's well over 1.5 meters, and I want to say closer to 2 meters long. So for a Psittacosaurus, really, really big. It's also basically got almost all its external soft tissue preserved.
Oh, wow.
It's got... The whole thing is completely covered with skin. You can make up almost every single individual scale. You can see things that are really obvious but very cool. So you can see like the pads on the toes. You can see that there are really small scales in the joints, which is what you expect. It gives you more flexibility. There are some big scales in places. Traces of the colour patterns are there.
Yeah, I was going to ask what colour it was.
This is one of those ones you can actually see the pattern on it full stop, because you can see these bands of darker and lighter patterns on it. But we've also looked at the trace pigments, and the melanocytes you talked about before shows that it was basically a browny top with some black patches and spots and a lighter underside, classic counter shading for a small animal.
I was very excited by counter shading and understanding it for the first time, which is I was like, but nobody's going to be under them looking up. Why does it matter? Because I always get confused with like fish. And then thanks to this podcast, I understand that by counter shading, it eliminates the shadow effect. So it makes you blend in more because you don't look like you fit, you know.
Yeah, your underside will be dark because of the light source above you. If you lighten that up relative to the rest of you, it will eliminate that and your shadow starts to vanish and you no longer stand out.
Which is amazing.
Yeah, if you're a dolphin or a shark or a fish, it's important because you're actually against a white background. But yeah, it works even walking around as well. So there's all of that going on. And then it's got filaments on its tail.
As in feathers?
Well, and as we've discussed more than once, who knows? But this is this was the specimen that basically blew open the idea that these filaments might be on beyond theropods and beyond birds and could be a much wider pattern. There's a block of them, so kind of at the base of the tail to about 2/3 of the way down the tail. So it's not like it's over the whole body or anything else. It's just this patch basically on the bum, and they're just little thin rods. They're like strands of raw spaghetti, so they're quite stiff with a little bit of flexion. They're about that thickness, and the big ones I want to say are 15-20 centimeters. So yeah, like
2 images in my head, and one is of a porcupine and the other is of a toothbrush.
Yeah, less porcupine, because those are really quite stiff and sharp.
I assumed that would be what it was about, but this is going to be another sexual selection thing. Not only do I love a boy with big, like, teeth coming out of his face, but I also really like him to have, like, you know, just the upper part of his tail, a nice big bushy spiky bit.
So there's not that many of them. It would have been a little bit of a kind of plumed brush. Yeah. So when they were first described, there was a lot of controversy over that, and people were like, "No, it's complete chance, and it's just sitting on a bit of plant. Otherwise, why isn't it over the rest of the body?" I still don't think it's actually been sampled. So I don't think anyone's actually taken a physical chunk off one of them and stuck it under a microscope. There were various issues with the fossil, which I don't particularly want to get into because we'll be all day talking about that, but it's been an awkward specimen. And I think it's fair to say there were questions about how it ended up in Germany, having left China, raised at times.
See our episode with Dan Schreiber.
Among other things. And then that caused some of those access issues. It's a specimen I've seen, but only on display. And I asked them to open the cabinet for me, and they're like, nope. So, okay, fine, I'll just look at it through the glass. I am told there's at least one other and possibly two other specimens preserving this same plume on the same bit of the tail, which, if true, would, it can't possibly be a coincidental plant just sat there on all three of those specimens. And, of course, subsequent to this, we found other things, other ornithischians, because this is a ceratopsian, it's an ornithischian, with filaments on, which also kind of counteracts that argument anyway. Though at the time, you've got to remember, this is a ceratopsian, and it's in the Cretaceous. Their last shared ancestor with theropods goes back to the middle or late Triassic.
Wow.
It's 100 million years earlier, or certainly like 80 million years earlier. So, and we'd never found another ornithischian at that time with them. So when people are going like, oh, well, they're just like feathers. And it's like, well, then what the hell's been going on for tens of millions of years in all these other different dinosaur ornithischian groups? We've never seen anything like this. So you can see it's very, very odd that you've got this huge gap, but then this, again, feather-like structure.
I'm right in thinking this is like up by the bum and not at the end of the tail. Am I getting that right?
So it's the first half of the tail. So kind of from immediately just after the hips. Well, if you want to look for a coincidence, again, we've talked about Protoceratops before. Those early Protoceratopsians, so you've basically got Psittacosaurus and its relatives is one big group. The next thing to come along is Protoceratops and its group, where they've got the frill, but they don't have any real horns on the face. And then you get all the classic Triceratops, Centrosaurus, Torosaurus, etc., where they've got the horns and the frill. Protoceratops and its relatives have a really expanded series of vertebrae in the first half of the tail. They're all really tall. So you've got this odd little expanded paddle shape, which looks, therefore, suspiciously like what a Psittacosaurus would look like if you looked at it side on, in that it's got this enlarged bit of the tail, which you would only see side on in the same bit.
So is that must be the bit that looks good?
I am suggesting that that's not a coincidence, that these two very close relatives have different mechanisms, but both gone for some weird base of the tail expansion thing.
I mean, if it is, it's reminded me a little bit of those lizards that you get with the throat things, where they're all of these different types of lizards have the dewlaps, as a way.
Yeah, they have these little throat flaps,
which have no purpose other than, hey, look at me.
Yeah, that's a good example of why I keep talking about sociosexual selection, because males will use them to signal females, but they also use them to signal other rival males and go, get off. This is my patch, which isn't sex, really. It's more social dominance and social sex.
Communication, I suppose.
Yeah, it's a intra-specific communication device is what it really is. But the Protoceratopsids have got something, are they supporting their own plume of filaments, which we've just never found because they're not preserving in the bed? Who knows? But this has led to people drawing really furry ceratopsians. There's suggestions of filaments in all kinds of ceratopsians as a result of Psittacosaurus having been found with them, though of course itself is still mostly scaly. And because, annoyingly, as I said, you're looking at this animal from like up underneath, and these appear to be on the top of the tail, we can't see the base. You can't see where they're going into the skin and how they connect, and are they between scales? Are they a scale themselves and coming out? You can't see because the animals turn over when you die, you stupid animal. So 120 million years later, we can look at you properly.
Or at least sort of die with some sort of like pole saying I am here.
Yeah,
you know.
Yeah. Flip the tail over. And then the other thing that we kind of have to mention, and this only came out last year, so, about the time we started, this time last year.
Is this the cloaca?
Yeah.
Oh my goodness, this is the
yeah.
creature with the cloaca. Because that was everywhere. That was all over the internet. I had people sending me pictures of a dinosaur's bottom, which I never wanted before, and then realised I did once.
Yeah, this is the exact specimen. So yeah, we have exactly one preserved exit. This is that exit.
Oh, imagine though, you've lived your life, you've died, it's very sad, and then the thing that you're remembered for millions of years later is your rear end. So this is, dinosaurs are like birds and they have a cloaca rather than...
And reptiles.
Yeah.
Well, and platypus and echidna. There's at least a couple, the earliest mammals still have the same thing, in that basically everything exits through
it's very efficient.
one exit.
It's very efficient.
Yeah, so urine, feces and any eggs all come out of the same spot. Basically, they've got the same, let's say, internal plumbing that we do. It's just that they all empty into this kind of like pre-exit, and then the single exit is a cloaca. We've effectively just cut that end bit off, and therefore have ended up with multiple.
I don't know about you, Dave, but I can't make shells, so
no. But yeah, but yeah. So and it's one of those little things where people are like, well, why are people interested in that? It's like, well, it does tick off a couple of boxes. We can see that it's a roughly vertically orientated slit. That's what you get in crocodilians, but not what you get in most other reptiles. So that actually ticks that box, and it's largely what we expected. The fact that it's there, it's always a possibility that they were doing something weird and different, and they're clearly not. Again, we had the melanosomes. They were able to dig some from that area and show that it was very, very dark. So in other words, it was kind of blackened around that area. But again, that's actually quite common in a lot of living animals. Flies, let's be honest, this is a nasty target for a lot of parasites. Having something that's a bright and obvious route into your body is not what you want.
But it rules out that they're not doing what like baboons and other mammals are doing.
Right. It might be 99% exactly what we predicted and expected, but it's still good to have it confirmed that that's exactly what it is.
No bright blue bottoms for...
No, or not that we can see, at least. Because remember, there's always structural colours as well, which might have been sneaking in. But no, it's basically got a black bum. But on the one hand, it's very academic in the sense that not too many people outside of academics are really keen on it. But it's also, as I say, this is the kind of data that, is almost impossible to access. For all the tens of thousands of dinosaur fossils that we have, and even for the thousands of fossils that we have now from Liaoning and these associated exceptional preservation areas, this is the one. This is the only specimen that we've got preserving
Psittacosaurus
really
bones.
Pretty important bit of their biology. That's our only record for dinosaurs. The fact that it's so similar to birds is actually really interesting, because again, this is an ornithischian. It's on the other side of the tree, and yet 100 million years later they've kept that exact process. Means it's
a good one.
Again, not a big surprise, but that's very consistent. It looks like everything's doing the same thing in the same way, yada yada yada. So pretty neat all round, really. Actually, that one specimen, scales, filaments, the pattern and distribution of scales, colour, counter shading, the cloaca, the size. It's a really big one that's about as big as they get. Gives you a good idea of the proportions. It's amazing. Oh, it's got a little bit of a kind of a raccoon mask going on as well. So it's kind of got a black stripes or black kind of band across the eyes.
Which does suggest, again, if we're looking at the cloaca and that was dark, that flies might be a real issue. Because that's where flies will head to, is your eyes and your...
Again, it could also be a camouflage thing. Lots of animals have either a white band or a black band across the eyes. It's very common for signalling or, again, to break up the facial outline.
And when you're going to rob a bank, so they might...
Well, yes. But, but there's a reason that, badgers, coatis, mink, there's various rabbit species, there's all kinds of different things, have rings around the eyes or bands across the eyes. Right. Raccoon dogs. Yeah, exactly. So again, these are very common animal patterns.
So explain
but
that.
Still seeing them.
Explain the dark patch around the eyes and what that does, because I'm confused. It just breaks up the face.
Yeah, so I mean, the slight problem you've got is, of course, that most animals are pretty symmetrical in that regard. But what you tend to have is eyes are often at least slightly sunken, or at least let me start that again. So those colour patterns tend to be fairly symmetrical, which actually isn't ideal for kind of breaking up an outline and stuff. But heads tend to be a very familiar shape. You tend to have a pair of big balls for eyes, and there tends to be a hole underneath the mouth, and particularly if you're a predator, most animals have pretty similar head shapes. Certainly all closely related species will have pretty similar head shapes. That's a key thing to kind of lock onto and identify. Eyes in particular, this is one of these things that, you can give to babies or newly born animals that can only just barely see, and they'll look at eyes. If you put a pair of dots on the wall, they'll look at them. Like, eyes are absolutely a thing that almost all animals recognize. And so if you don't want predators to lock onto you, you want to kind of break up that face pattern and that face shape. And one of the ways of doing that is put some, really big, thick, contrasting lines across it, which again will kind of interrupt shadows. When you do, if you're in the army and they'll teach you to do camouflage, of course, the one thing that they get you to do is put black kind of on under the eye on the top of the cheek, because that's the lightest bit of your cheeks. They kind of stick out slightly from your face. They will catch the light. They will be very light. So you darken them up, and it will change, therefore, the shape and colour of your face, because you're eliminating that silhouette pattern that you would get from the light and shadow on you.
Cool.
And I imagine they're doing something fairly similar.
That's really cool. I'm annoyed that I didn't know that Psittacosaurus was not only a dinosaur that mattered and told us a lot about, and was the bum dinosaur, but also there's one of my favourite dinosaurs growing up. Didn't know that. Just because watching it breathe while it was having a sleep was the best thing. And going, no, it does move! It does!
Yeah. Because it just, yeah. For any, all the Americans listening to this are going, what the hell are they talking about? When you go to the Naturalist Museum, and hopefully you will one day, you'll see this little thing, and it's one of the nicest models there. Actually, it's really, really well made.
They've got like this whole thing of like a load of velociraptors, or I don't know if they're velociraptors.
They were supposed to be Deinonychus, yeah, but old Deinonychus with the really kind of blunt head,
and also not feathered at all. And
then they stuck some feathers on them, now they look like someone stuck some feathers on an old model of Deinonychus. And
there's like they're eating something that moves a bit as they're eating.
Yeah, that's been removed. Yeah.
Okay.
I mean, it's one of those things, when they were made, because I remember going to the Naturalist Museum when they first put them out, and they were pretty cutting edge and good at the time. It's just they're now 30 years old, and they don't work very well.
When I was a kid, though, the best model was the Psittacosaurus. So that is awesome.
Yeah, it still is.
So our guests this week, you see, they know Dino more than even I know Dino. Not probably as much as Dave knows Dino, but they do know Dino. They are Garret and Sabrina from I Know Dino, and they're going to ask you a very nerdy question, I imagine. So we should really get on to them. And if you don't know the I Know Dino podcast, they cover all the latest news in dinosaurs, and they've been going forever. Anyway, here they are. Because you do the most, amazing, when I was looking going, should me and Dave do a dinosaur podcast? I bet there's loads out there. Yours is number one. And I listened, and it's amazing. Thanks. And you guys go really in on the detail. So much on the detail. So tell us and our listeners a little bit about how your podcast started and why it started.
Sure. So we always start with our wedding, because we had a dinosaur-themed wedding. Mm-hmm. And I guess obviously we talked about dinosaurs before that.
Right.
Because you don't just have a dinosaur-themed wedding out of the blue.
If that was spontaneous, that was... someone did very, very well to guess. I think she'll like that.
Exactly. Yeah, we had a dude in a T-Rex.
His name was Duncan.
Yeah.
Duncan the T-Rex, yeah. Because we got married at a zoo.
Yeah.
And Duncan was meant for educational purposes. So
Mhm.
usually he'd go out for the kids and teach things. But they knew we liked dinosaurs. So they said, do you want Duncan at your wedding? And we were Duncan's first wedding.
Mm-hmm. So that was cool. It was one of those like pretty realistic ones where it's like a guy completely hidden inside the suit.
Mhm.
That's, 10, 20, probably 20 feet long, I would say.
Right, so he's got the
And an
animatronic
head.
face. Yeah. And so all the adults loved Duncan, but any kid under about, 10
Mhm.
cried when they saw Duncan. It was
terrified.
too realistic.
Because it
Yeah.
looks like it's
It's what you wanted a wedding. That's exactly what crying children. It adds to the ambience.
Exactly. So then we started, I guess, there and then with crying children. And then a few months later, I was looking for a podcast about dinosaur discoveries because there are so many all the time.
Right.
And I couldn't find one.
There's some really great paleontology ones, but they weren't dinosaur specific.
Yeah, there wasn't anything covering all the discoveries. And I was like, I need to know how to say these names. I need to know what this new dinosaur is and all that. Nothing was keeping up with the insane pace. So then we decided, well, we'll just keep up with the insane pace, I guess, and make our own podcast. So that's what we did.
Amazing. You've actually had Dave on your show before.
Mhm.
I was
2 or
just
3
looking,
times, I think.
Three times, yeah.
So I can't imagine you having another question that you need to ask him. That's basically all his info that you've got anyway. But is there a question that you would love to ask Dave?
We always have more questions. I say that I could talk about dinosaurs indefinitely, or really any subject indefinitely, but dinosaurs especially.
Yeah.
So I guess one of the things, I'm going to really go like deep weird here because we've already talked about so many things. So we were just covering a new Unenlagiid, those like South American
Yes.
dinosaurs.
They're not my favourite topic. I'm not sure we've ever even mentioned them before. So this
Good.
might be a very short segment. Keep going. Yeah.
Well, we could switch it around into something else because it's
Dave not knowing stuff is exactly what I want on the podcast.
So the question basically is they've been proposed as semi-aquatic, much like Spinosaurus has been proposed by some, you may know, as semi-aquatic. I was curious if you had any opinion on the features that they have in common or not that might lead one to that conclusion.
Not really, because I kind of hinted. I know almost nothing about them. I mean, I remember back in the, I want to say 2004, 2005 time when I was finishing up my PhD, which for listeners who don't know, wasn't actually on dinosaurs. My PhD was on the origin of pterosaurs, which of course went back into early dinosaurs, and I was supervising some undergraduate and master's projects on dinosaurs, and I even helped teach on the master's course, but they really weren't my thing at that time, and my dinosaur knowledge was pretty basic. But as I remember correctly, at the time they were kind of considered either just a weird dromaeosaur or even possibly an early bird, which happens with a lot of those things right around that area. At the moment, I can say off the top of my head, I wouldn't even know what the current consensus is of where they fit, though of course, again, there isn't much consensus about where all those groups go anyway. But to my knowledge, like, they're all extremely fragmentary. Do we have any Unenlagids that are like more than bits?
I think the closest thing we have to a whole one is probably Halscaraptor, but I don't think that, I think that's an Unenlagiid, but not an Unenlagiine. It's like the Velociraptorine sort of specificity
so it's
thing.
Close, but not a particularly derived. Yeah, so Halscaraptor, and I know I'm saying that not quite how it's pronounced, is one described 3 years ago now, by Andrea Cow and colleagues, and it's a Mongolian thing. Well, it is. It's a thing. I mean, that's a magnificent specimen. We've got almost all of it. It's this weirdly long snouted, so very velociraptor-like and about that size, but with a really long head and then weird arms and weird joints. And the suggestion for that is that it's actually quite a good swimmer, but obviously kind of paddling rather than penguin-like or anything more derived like that. And it has got a couple of odd features about it, which I think it's more credible as a good swimmer than Spinosaurus is, though not a big spoiler alert. That's not saying very very much because I don't think Spinosaurus could swim very well at all. But yeah, as we say, they're all fragmentary beyond belief, and therefore it's hard to really say anything about them as whole animals. They do have these very long, thin heads with lots of teeth in, which is a pretty common fish-eatery thing.
Yeah.
And that's about as far as I'd be prepared to go. But of course, that fits perfectly back into the Spinosaurus thing, because Spinosaurus and Baryonyx and Suchomimus and the others have great big long skulls with lots of teeth in, and they're probably eating a lot of fish. But that's not synonymous with being able to swim very well, as herons ably demonstrate. You can eat almost entirely fish without actually being able to swim.
I mean, I quite like fish, and I'm not very good in the water.
We're just talking about, humans are terrible for swimming.
Yeah.
And my cats, actually, thinking about it. My cats are very unsuited to the meals they eat. I mean, even they like the lamb pouches, and even those, that lamb are very protected with wool, and that stops the cat getting in.
And the pouches, I've never seen them open one.
Well, I saw on TikTok a cat opening a pouch, as in it eviscerated the pouch and eaten. It had bitten several pouches to find the flavour it wanted and gone for one.
What a wonderfully cat thing to do.
Yeah,
exactly.
As big of a mess as possible, I think, is the goal there.
Yeah, so unenlargines, don't know, maybe. This isn't much of an answer.
Yeah, I think you're right about the teeth. So I think the main argument, right, is they have more conical teeth than other dromaeosaurs. They're not particularly serrated, all that.
It's another case of need more fossils.
Yeah, but it's like they ate fish, I think, is where we're at. And then, like you said, Halscoraptor especially has the weird joints. And I think they described it as like sort of mergus. I don't even know if that's how you say it, but it's a type of bird, type of duck.
Yeah,
that, like,
mergansers.
swim with their wings. Yeah. So they like sort of fly or like flap.
I love the way you both go, mergansers. What?
Mergansers have these... We looked at a merganser when we were in St. James's Park. Weirdly serrated bills, very long and thin with these like jagged serrations along the edge. They're not what... The rest of the animal, very duck-like, but it's like it looks like a duck until you look at the bill and then you go, oh, that's weird. And yeah, they're definitely little fish hunters. But yeah, this goes back to other conversations we've had about like, behavioral plasticity. If you look at something like a jaguar, it doesn't look very well suited to swimming at all. And yet they swim pretty well, enormous brackets, for a cat. So, they're much better swimmers than other cats. And therefore, when they do things like, there's wonderful videos of them, jumping off trees and on banks onto caiman and capybara and underwater going after big fish, they're obviously doing something that a leopard, which is gross, morphologically almost identical to a jaguar, is not doing and not capable of doing. But that doesn't mean that, if you put them in a race with a barracuda, they're actually quite quick. So yeah, being better at something and maybe even quite specialized for one side of things can, the behavior can still smear enormously around it in lots of convoluted ways. And this goes back to a lot of my moan, not really about semi-aquatic per se, but actually loads and loads and loads of behavioral terms in paleontology, because they're often so extraordinarily poorly defined. As I've said in one conference talk, I spotted that Wikipedia at one point listed Asian elephants as being semi-aquatic. Now, they can spend quite a lot of time in water, and famously, out in Indonesia, they swim between islands in open ocean. But I still think it's a hell of a leap to call those animals semi-aquatic. But if they're semi-aquatic, then dear God, yes, Spinosaurus is. But that's because no one's actually bothered to define semi-aquatic, not that Spinosaurus is or isn't. And this is why I prefer, and indeed I've written about this in a paper, I prefer analogues. If we say semi-aquatic in the sense of a jaguar, or semi-aquatic in the sense of an otter, those are pretty obviously different things, and people know roughly what they mean. Otters are really quite tied to water and spend a lot of time in it and are doing very watery things with some real specializations for swimming in a way that jaguars aren't. And then again, and then go, and then have sea otter above otter, or, something even more, seals or sea lions. There are gradations, or at least behavioral or ecological analogues, which I think give a much better sense of something than going, it's semi-aquatic, or it's social, or it's a scavenger. Yeah.
Mm-hmm. We need more fractions. Semi implies half. We need like 16th aquatic, quarter aquatic, 3/4 aquatic.
Pretty much, except of course, even half. What does that mean? There are crocodiles that barely leave the water, and there are crocodiles which will spend 9-10 months of the year in the desert.
It's like penguins spend a lot of their time outside the water, just to breed and stuff. So it's like they're really like, aquatic dinosaurs.
Yeah, if you're an emperor penguin, months on the ice at a time.
Even though they can barely move on land.
Right. It's precisely, and this is another thing I think that people miss. I talked about this in one of my papers, is that there's the idea that I think kind of being specialized for something means you do it all the time. So a point I made is that, you've got things like octopus with I want to say it's the third arm on the left, but in any way, male octopus have one specialist tentacle that has this groove on it, and it's for sperm delivery. And a lot of octopus die once they've bred. So they use that thing once in their entire life. But it's unbelievably critical to their survival. So, of course, they've evolved it and honed it and specialized it. And, so important is not the same as, everyday usage. And I think that's often a big mistake as well. Yes, I think she's...
So I'm making filthy jokes in my head.
I'm sure you are. But, but a similar thing, with Spinosaurus. It could, let's just... I'm not suggesting this is the case. You could just speculate wildly. They live in an environment which periodically, every few years, dries up almost completely, and the only way you can get from area to area without walking across a baking desert is to swim. If that is that crucial to your survival, you will develop some swimming adaptations. But it means you use that once every 5 or once every 10 years. But we always tend to look at things, or I think a lot of people tend to look at things and go, if it has that feature, that's like its whole lifestyle. And it doesn't work like that. And equally, if you don't have it, you can't do that, which again is not, you can see videos of lions swimming and climbing trees, which are things people don't really associate them doing. There's records of crocodiles going up trees, and no one would look at them and think they're good climbers.
And that could be a fatal mistake.
Yeah. Well, curiously enough, usually only the small ones and not very high. But the very fact that they're capable of doing it, I think, is well beyond what most people would expect them to be able to do. Mm-hmm. And it's understanding that behavioural and anatomical flexibility. Nice. And that's kind of important. I was going to say, I've managed to bang on for quite a long time about not very much.
You managed to get from a question about a South African dinosaur into an octopus's sexual adaptation, which I think is... Exactly, I think they must do.
It's the beauty of science.
So my follow-up question is going to be barely related, but because you were mentioning... As they, it's like people do at SVP, they'll be like, I have 3 questions, and they're like just in completely different worlds. 2 follow-ups.
Each one of which has several subdivisions. Yeah. And
you were talking about, there's nothing in my mind more fragmentary than pterosaur fossils in general, but are speaking about weird ducks and things. Are there any pterosaurs that had any duck-likeness about them, like that we think were adapted for fish or anything like that?
In the sense of kind of duck-like dabbling with that little thing you see where the beak opens and shuts really super quickly and the water kind of flies everywhere. Yeah, there's a few. So, ducks that are doing that are often basically being weird forms of flamingos because they're doing kind of the same thing. They're processing large amounts of water very quickly and trying to sieve out the few things that they want to eat from that. And yes, there are pterosaurs that mimic flamingos very, very well. Famously, a thing from South America called Pterodostro, which has literally hundreds. I think it's like 1,000 or 1,100 very, very, very thin teeth on this very curved jaw. And as far as we can tell, they're filter feeding in a soda lake, so just like flamingos. But Pterodactylus, like the definitive kind of pterosaur, literally the origin of pterosaurs and the original inverted commas pterodactyl. Pterodactylus has a whole bunch of little teeth. We've got a couple of them having eaten fish, but they haven't got really like fish-eating teeth like a lot of their contemporaries do. And a bunch of the rest of them, so Pterodactylus is part of a group called Ctenocasmatids, and Ctenocasmatids includes Ctenocasma and a thing called Gnathosaurus, and there's a new unnamed thing from Germany, which I've been waiting years for people to name, and keep being told, oh no, it's coming soon, Dave. No one's done anything on it for like 15 years. It appeared on my blog It's on my blog from years and years and years ago because I was told I could put up photos of it, and yet no one's described this complete, perfect new fossil. But all of them have a really quite long, thin snout with lots of fine teeth to varying degrees. I mean, in Gnathosaurus in particular, they stick out wildly, like straight sideways. But as far as we can tell, they're all doing something fairly similar and just kind of, doing that dabbly thrashing around, as it were. And there's probably a lot of tongue action and stuff like this to push all the water through, and so they can eat little bits. So in that regard, they're really quite ducky.
Are there not adaptations for grooming or things like that?
Probably not, given that they often have this very spoonbill-shaped beak or bill that goes forward and then out sideways into a triangle or even round into a little spoon shape. And again, the very modern bird that eat fish jaw shapes are probably not for grooming if they're eating fish. And again, with pterodactylus at least, they've got fish in the stomach. Pterodostro aside, which is South American, all the ones I've just mentioned are all from the Solnhofen beds of Germany, where we get Archaeopteryx from, but also is a series of lagoons around a series of reefs. We would expect lots of shorebird-like things that are grabbing small animals and fish and stuff out of the shallow water, just like we see with things like spoonbill. It's probably not a big surprise.
Does that answer your question?
It did.
Hooray!
I honestly forgot that pterosaurs even had teeth, because that's how little I know about pterosaurs.
Oh, they got. Dave was on BBC News over the weekend, which shows when we're recording this. But they showed a picture. They said, "Look, we found a dragon," and you see Dave's face turning into a dragon when he goes, "Not quite," with the gritted teeth.
It was more that they said, "How do you define a dragon?" It's like, well, I don't, because they're not real. But I thought we were talking about pterosaurs, curiously enough.
Is that how you answered it? They're not real.
Yeah, quite literally. Yeah. I said they're mythological.
Just, all the children's dreams. All the children listening.
Well, they shouldn't ask such a stupid question on live television.
It's light-hearted.
Scientists aren't light-hearted in
the
facts.
So the thing, it came about because the lead author, a guy called Tim Richards, who I know a little bit, had said in the media, this is an Australian find, it's the closest thing we have in Australia to a dragon. And you can see where he's coming from. It's a big ornithochirid, it's 7-8 metre wingspan with these big teeth, it's a big flying reptile. That's not a terrible analogy in that context. And again, you lift that statement out of the rest of the description, and it has the potential to be misinterpreted. But they quoted him verbatim and said, it's the nearest thing we have to a dragon.
Yep.
As in, we understand that this is just a quote and not really what it is, and then asked me about dragons. It's like, well, so yeah, that's how that went. I think the rest of it went pretty well, but yes, as usual, the first 5 seconds of a live and unrehearsed broadcast, you don't know what you're getting. And if that's what they're going to lead with, you're going to have to go with it.
Please ask your next question is, are there dragons? Please.
Do they breathe ice and fire? So going back to the semi-aquatic thing, then what would be a good way to think about these terms when it comes to, I guess, like Spinosaurs or other types of, when we talk about these semi-aquatic dinosaurs and what that means?
Oh, it's difficult because, again, you've got this term which is not just kind of understood by the general population. I mean, if you drop that in a conversation, I think people immediately understand kind of what you're talking about, even if they've never encountered it before. But so it's also extensively used in the scientific literature. And again, when you're talking about frogs and crocodiles and sea lions, it's fairly uncontroversial. And if you're talking about platypus and jaguar, people at least know what their general biology is. And so it may not be the best term, but it's also not too awful. And it's not, you can go and read a couple more papers on jaguar behavior and soon work out that, well, it's not, it likes water more than other cats, but it's not some kind of specialist swimming cat. And yet you don't get that with dinosaurs, and therefore as soon as people drop that term, as Garret said earlier, it implies half and half. You literally use the word semi in there. It implies some kind of equality between those two things. And yet, you've got animals like tapir which swim really well, but it's not like they're just living in water all the time. And other animals that, I'm trying to think of one off the top of my head, but there are things that swim very well but don't necessarily swim that much. And so, and everything in between and all around it. And so,
I mean, things which aren't adapted for swimming swim a lot. I mean, there are some people.
That's true. There's plenty of humans.
There's plenty of fishermen and stuff who, go diving every day and use it for food and the rest of it, and that happens, and we are not particularly adapted for water.
Yeah, is it the Ama people in Japan who are the oyster or pearl divers and supposedly have really good lung capacity and stuff, but they don't have webbed hands.
Not compared to an otter.
Yeah, that's the thing, they don't have webbed hands and dense bones and the things you might expect. So I think it's a question of not necessarily abandoning that term, but definitely giving it some context, using a clear analogy, or just looking at the degrees of adaptations that are available. And this ultimately goes back to the Spinosaurus argument, is just how good are those lines of evidence for various individual little bits of the skeleton? Because different animals have adapted to do different things in different ways. Hippos are not swimming in the same way that penguins are, in the same way that terrapins are, or platypus or otters or dolphins. But you can still see some things in common between all of them, as well as all those different things. But if you start seeing a big long list of that stuff, at the bare minimum, you've got an animal spending a lot of its time in water. And again, for the record, I'm suggesting that Spinosaurus probably is spending a lot of time in and around water. The real crux of the debate for the last year or two has been how well could it swim, which is a different question entirely. As we say, there's animals like tapir and capybara and jaguar, which swim better than their terrestrial contemporaries. In a race underwater, capybara are going to be beating your guinea pigs by a considerable margin. And
please don't conduct this experiment.
And jaguars will happily outpace leopards or lions in water, but that doesn't mean they're a great swimmer in the grand trajectory of swimming speed. They'd be closer to us than they would towards fish or dolphins that really have got it nailed down.
Mm-hmm. And none of them have a massive fan on their back.
No. So. There was a beautiful video. You may have seen, I retweeted this about a week ago. Some Japanese person on Twitter had this nice footage of a dead sailfish and were pulling the fin up and letting it drop back down. And I've seen multiple people go, Spinosaurus is a fast swimmer because it's got a fin like a sailfish. And it's literally collapsible, and it collapses into a socket in the body for streamlining. This is kind of the antithesis of 2 meter tall block of bone. They're not the same thing.
Yeah, but that one that was found has this vaguely sailfish-like, silhouette to it, which really it's hard to unsee.
Yeah, but that's all it takes for people to draw those analogies. And it's like, your comparative anatomy needs to be functional morphology needs to be a little bit better than that.
Well, I'm going to let Garret and Sabrina go away now and find some guinea pigs to sew on the sails to, and then put them in the water with the capybara and the jaguar and see what happens. So that was really good. Can you just plug everything now? So it's I Know Dino, the podcast.
Yeah, I Know Dino. We have a website, iknowdino.com. If you any podcast app or YouTube, if you want to listen to us, just search for I Know Dino. And actually, that same goes for all our social media. I think we're on almost everything. What's that? Facebook, Instagram, Twitter. We are on TikTok. We're not very popular on TikTok.
Oh, I forgot to mention, the most recent dinosaur we did was called Ipupiara, which when I wrote it out phonetically, I was like, oh no, that's not good. But that's the Unenlagiid that we talked about in the most recent episode.
Is that the half jaw that's just come out of Brazil that got lost in? But it's the specimen that was lost in the fire, right?
Yeah.
So it's a description of a specimen we don't even have anymore.
Yeah. We got some pictures.
Mm.
It's pretty cool.
Maybe we'll get lucky and it'll turn up.
Yeah. It's very small. It's like smaller than the palm of your hand. So maybe it's just under the last unturned rock.
We can hope.
Yeah.
A massive thank you to Garret and Sabrina there. That was amazing. I didn't know anything about anything, but I'm sure that's fine. I'm feeling like a chump anyway. And
I didn't know to look up Unenlagiens because I didn't know they were going to ask about a group that I know almost nothing about.
I think you did well. You covered well. Brilliantly done. Nobody knew anything at all. It was fine. We're also a guest on their podcast as well, which has been released or will be released least I'm not sure what our plans are. But there we go. So that is Garret and Sabrina. Go to iknowdino.com for more information about all of their millions and squillions of episodes. So a huge thank you to them. Do check out little images of the Psittacosaurus. If you take out the S, then it's the Psittacosaurus, which I'm very hungry now. My tummy is rumbling. Do you think they would have tasted good? Because they are ornithischian, which means they won't be tasting like chicken.
I mean, I bet absolutely everything ate them. I think they're the small gazelle of that bit of the Cretaceous, and they're absolutely everywhere, and there's loads of them, and they're not covered in armour and spikes and horns, and they're not really, really quick. Everything ate a Psittacosaurus.
They've got little brushes, which could be a bit like artichokes, things, so you can't eat them tail first.
Yeah.
I mean, that could have been defence as things are biting through the lower tail and paralysing their legs, maybe.
There's at least one decent-sized allosaur or megalosaur there for which they'd be a perfectly sized prey item, even an adult, and yeah, I bet they just chomped through them.
Their skulls get stuck in their neck, all those big spikes, you can't eat them head first. Maybe that was partly the defence, it gets stuck in the neck of an allosaurus. Oh. So, with that, why don't we do an allosaurus with a Psittacosaurus stuck in its throat, roar, to welcome us back to the new series. After 3, 1, 2, 3. Okay, do a proper roar, This episode of Terrible Lizards was made possible by our generous patrons on Patreon. To support the show and for bonus content, please go to patreon.com/Terrible Lizards. For links to everything, including merch and past episodes, go to terriblelizards.co.uk. Please follow us both on Twitter. I'm at ISZI_LAWRENCE and Dave is at DAVE_HONE. Send us your questions either via Patreon or terriblelizardspod@gmail.com. If you can't afford to support us on Patreon, please do write a review and recommend the show to your friends. Thank you so much for your support. It means a lot to us.